Hi, Year 8s. In this video, I'm going to be going through 4D areas of kites, rhombuses, and trapeziums. So there's a few more formulas that we have to look at. So in the previous lesson, we were looking at areas of rectangles and triangles and things. And this time we've got so it would pay for you to copy out these with the heading of 4D, areas of kites, rhombuses and trapeziums, and of course if you can copy this theory down. But that is basically that we're finding the area of a rhombus or a kite. So a rhombus is a parallelogram with equal side lengths. You can see there that all these side lengths are the same. And what we notice is that these angles or these diagonals actually intersect, and they these sort of form a right angle. So you'll notice these rhombuses, and likewise with a kite, we're also looking for. This looks similar to a rhombus, except we've got sort of two pairs of um, uh, of um, sides which are of equal side length. So so you can see there that these are the two side lengths, and over here we've got 1, 2, both the same as well. So likewise, we're looking for these diagonal. We're looking for these diagonal distances. So what we're looking for here, and you'll be given these in your diagrams and things. So we're looking for this diagonal is x, and this is y. So we are after that one diagonal we'll call x, and the other diagonal being y, and the area is a half times x times y. Okay, so that's the area of a rhombus or a kite, and likewise, we've got the area of a trapezium. Now, with a trapezium, we've got 1, 2, we've got a pair of parallel sides, and then we've got a pair of sides which are not parallel. So you can see here, we've got there, and of course, when those two pairs of parallel sides meet with two other lines, then what we form is a trapezium, and that has what we call a perpendicular height. Again, notice it's a right angle here. Okay, so that's a right angle. That's the perpendicular height. Okay, and now it says here the sum of the parallel sides. Now the sum of the parallel sides, they are b and a. So if we put those together in a fraction, we're looking at a plus b in brackets. Okay, multiplied by the height and then multiplied by a half. Okay, so there you go. They're the formulas which you'll need to familiarise yourself with. Copy in your book. And now let's go through a couple of examples. All right, so the first one, what do we got? Well, first of all, we're looking at 1, 2, 3, 4 sides, and those 4 sides are equal. So we have a rhombus, and of course, a rhombus, the area of a rhombus for A is equal to a half times my diagonals. You can see here that we've got that one diagonal, and these diagonals, of course, are also going to intersect at 90 degrees, and it's actually in the diagram there. So we've got half times, we'll call this diagonal here, x, and the other one y. It really doesn't matter which one is which, to be honest, because of course, when you multiply two things, you're going to yield the same result. Okay, so we've got a half times 8 times 5. You can use a calculator. 8 times 5, though, is 40. A half of 40 is 20. And of course, we're looking at area, so we're looking at meters squared. Now, you might be asking yourself, what is this shape? Well, we've got 1, 2, those two side lengths are the same. We've got a quadrilateral, and we've got two sort of pairs of equal sides. So this is, of course, our kite. And our kite, likewise, it's the same formula, a half times x times y, where these two things are the diagonals. Okay, so of course what we're looking at is those two diagonals intersect, and they intersect at right angles. So we've got 20 here. So we'll call that x. That's going to be 20. They intersect at right angles, and that's how we know that they are diagonals. And then we've got 10 centimeters. So we've got everything we need to throw into the formula: half times 10 times 20. 10 times 20 is 200. Half of 200 is 100, and of course it's centimetres squared. Really important to show you units. Of course, it's not 100. I want you to say it's 100 centimetres squared in this one, 20 metres squared in this one. And of course, for C, what do we have? Well, we're looking at, finally, we're really looking at, we're looking at 3 different quadrilaterals. We're looking at rhombus, we're looking at kite, both of which really do have the same formula. And then a trapezium. Now, let's have a look at what a trapezium is and look at the unknowns. So we've got, or not the unknowns, but the variables. So we've got A and we've got B. And A and B are my 2 parallel side lengths. You notice here we've got 3. Now, you can't just interchange them. Okay, so we've got to get these right. Okay, these ones here, X and Y, you could have interchanged these 2 and it wouldn't have mattered. But over here, if I do it in a different color, what we've got is that A, as long as these 2 are your parallel, these 2 here are your parallel lines. Okay, and of course, a trapezium has 1 set of parallel lines. There it is. Those 2 are parallel. You can indicate it by the arrow, of course, and they are, one's 3 millimeters and one's 11. We'll deal with the units in a second. Now, of course, we're going to have to ask yourself, were they all the same unit? Yes, they're all in millimeters, so we're okay with that. So be careful because sometimes you have some conversions. And what we've got is the area is equal to, now it's a half in brackets A plus B, and then we multiply it by the height. Really important, I think, when you're doing this, write out, especially when you're doing these early, write out the formula, then apply. And of course, we should know here that their perpendicular height, this distance here, which is right angles, is 5 millimeters. So we've got H is equal to 5. Let's throw it all into this formula. Area equals a half. So let's do a half. Let's do in brackets A plus B, 3 plus 11, and then that's going to be times by 5. Okay, and of course we work our way from left to right and we deal with brackets first. That's BODMAS, isn't it? 3 plus 11 is 14, so I can do times 14 times 5. I reckon we can do this in a head because 14 fives or 12 fives are 60, 13 fives, 65, 14 fives, 70. A half of 70 is 35. And of course, now I want you to consider what the area is. So we're looking at millimeters, aren't we? Millimeters squared for area. We're always looking for squared for area, aren't we? Because we're looking at 2 dimensions, 1, 2. We're looking at sort of 2 dimensions, 1 and 1 dimension being this side here, and our second being here. So we're looking at area is always squared, isn't it? Okay, so there you go. Now that I've done these, I'll get you to pause this video and have a go at these ones here. I'd like you to have a go yourself. First of all, I want you to identify what the shapes are, of course. Give it a name. It's asking for the area, but of course, before you need to identify what the shape is. Then from there, you're going to find the formula, which of course you can have a look in your exercise book. You can have a look at the top of the notes. Put in the formula, then work out what your variables are, and then go ahead and find it. So I'm going to pause this. I'm going to reveal my answers shortly. All right, so let's hopefully you've had a bit of a go at this. But for the first one, we have 4 equal sides, and we're looking at, it's like a parallelogram. A rhombus is a parallelogram, okay, where we have 4 sides are equal, which means that we can use the area is a half x times y, and we can say that x and y being a diagonal, 6 times 4 is 24. Half of 24 is 12 meters. Over here, we've got 2 pairs of side lengths that are equal. And of course, if we were looking for all of these are quadrilaterals, and of course, but if 2 pairs of side lengths are equal, so we've got this side here is equal this side here, and we're given our 2 diagonals, and again, we're doing our area equals a half x times y. And of course, x is 12 and y is 5. 12 fives is 60. Half of 60 is 30. I reckon we could do this without a calculator. Of course, if you're doing these, you can use one if you like, okay? But I think the better and better we get at trying to do some of these things and involving a little bit of fractions and a bit of multiplication. We've been doing 12 fives since I think grade 1 or 2. So just think about 12 fives are 60, a half of 60 is 30. Now with this last one, I haven't quite finished this last one, but these are the ones that are going to be the most challenging because, of course, you can get these things mixed up. So the pairs of parallel sides we're looking at the two pairs of these parallel sides here. It does matter, of course, it doesn't matter what x and y is. Your two diagonals, as long as you multiply them and multiply it by half, you're going to be just fine. But of course, our two parallel side lengths here, let's identify what they are. So I'm going to call one A and one B. It doesn't matter which one's which, but A and B both have to be one of these parallel sides. And what we're looking at, of course, we've got one pair of parallel lines and two lines, but of course these are not parallel. We've got a quadrilateral. This is a trapezium. Notice for the other ones we've got two pairs of lines which are equal, and of course they also meet at 90 degrees and all of those things. We're looking for the perpendicular height though, which is also provided. So the area is equal to a half the sum of the parallel sides times the height. Okay, so let's write out the formula. We know that what A, B, and H is, and now let's go apply that across. Okay, A plus B is 10 plus 6 in brackets, and then we're multiplying that by 5. Okay, we can do multiply if you like, but of course, yeah. Okay, now let's go ahead and work our way from left to right. So of course, when doing BODMAS, we do brackets first, don't we? So we brackets. Okay, let's do our brackets first. So let's evaluate everything inside the bracket. 10 plus 6 is 16. So that's a half times 16 times 5. And of course, if we're looking at 16 times 5, 12 fives are 60. We could add 5, 65, 70, 75, 80. Half of 16, though, is 8. Add a 0 is 80. 16 fives is 80. And a half of 80 is a 40. And, of course, now when we've done all this, I would like you to have your units at the end, please. Okay, so we're looking at 40 millimetres squared. All right, I'm pretty confident that if you practice enough of this in your coursework for 4D, then you'll be perfectly fine. Just remember that I've given you the solutions as well. I've put those in Microsoft Teams. And look, I hope that makes sense. Go and practice that, and I'll see you in our question and answer and theory lessons next time. All right, thanks everyone. Hope that this makes sense. Go and practice it now, and I'll see you soon.